Remember when we talked about trigonometry? And we said that a tangent was a part of trigonometry? Well, a secant actually is too. We didn't talk about secants because we only talked about sine, cosine, and tangent. But secant would be like an inverse of one of those. Meaning you're taking that and you're flipping it over. Secant goes with cosine. So you would take your cosine and flipping it over would give you secant. But again, that's down the line. That's probably algebra 2 or even pre-calculus kind of stuff. The secant that we're going to talk about today deals with lines again, like we had with our tangent, right? So yesterday we talked about tangent lines, and again, Cam brought it up. The first part to the second part, when we were talking about those vocabulary words, I think the reason that you couldn't use that segment in the between is because when they were talking about between those two circles, they were talking about tangent lines. Okay? So a secant or a tangent was a tangent because it only did what? One time, right? And then it was at the point of tangents. A secant is going to be a line that intersects a circle at exactly 2 places. So there's a lot of ways that you can do this kind of. So if this does this, everybody try to draw a circle again. Everybody try to, well, not try to, draw a line through there. And if this is true, what does every secant? It has to have a chord, right? So when we say this, we're still going to name our secant by the chord that actually touches. Okay, so if we call this AB, it's line AB, right? But we can also say it's chord AB. Remember what a chord was? A chord was simply the endpoints were on the outside of my circle.
But how come if it's only on 2, you said yesterday you can't go through the middle? Like you couldn't have that little.
But that's where you couldn't use a ray or a. That's where, because yesterday was a tangent.
Yeah.
So if it's a tangent line, there's no way that I could go through the middle and have it only touch one time.
Yeah, but isn't it still touching all that stuff in the middle?
We're on secants, yeah.
Because you said yesterday it was touching all that stuff.
Right, and that's when we were talking about this, the segments.
Oh, okay.
Because that's where I was thinking that they were saying that all those pieces of the segment were touching it. Then when I re-looked at it, the reason I think it was because they just wanted you to consider lines there.
Oh, yeah.
Okay, so it has nothing to do with the middle pieces touching the middle.
Yeah.
It's more of a ring than a circle.
Okay.
You know what I mean? So it's an open thing. It's not like a sphere that would have the ball would be. Okay. And I would totally agree with what you said.
Yeah.
In both cases, but I think that's what they're considering. Okay. All right. So from here, then we start looking at some theorems. And again, this is something that you really need to concentrate on. Okay? So again, if you're a words person, if 2 secants intersect in the interior of the circle, then the measure of the angles formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. What? Right? So, do you want me to write those words? Or do you want to just see a picture? So here's my picture. Draw this and draw 2 lines that cross inside your circle. Okay? So like this. And for argument's sake right now, you can do this anywhere, but I would try to do it a little bit more towards the middle, but it doesn't really matter where you go. Okay? So would you all agree that these are secants?
Yeah.
Okay? So then let's go back and let's put some endpoints. And let's call it J's. Okay? Bless you. So what this is saying here, let's read it again. 2 secants intersect on the interior of the circle. We did that, right? Here's my intersection right here. What should we call that?
P.
P. Okay? the measure of the angle formed. You see that, the angle that they're talking about? So we could be talking about two different angles. We could be talking about, P is the point, but I'm going to name the angles numbers. So we can be more exact. So I'm going to name 1, 2, 3, 4. What would you say is true about 1 and 3? They're vertical angles, and then obviously 2 and 4 are also, right? Are 2 and 4 equal to 1 and 3? Not necessarily, right? Because 3 and 4 would make up what? A linear pair. So they're equal to what? 180, okay? So if 1 and 3 are my vertical angles, they are what to each other? They're congruent, okay? Now, this is where the confusion sometimes happens. So it says, the measure of the angle formed. So let's look at just 1 and 3. I'm going to erase 2 and 4 so we don't get confused. I'm just looking at 1 and 3. So when we drew these two lines, we formed those two angles. Good with that? Okay? The measure of that angle. So, the measure of angle 3. But when I say the measure of angle 3, I could actually say the measure of angle what? 1. They're synonymous, right? They're the same thing. Is equal to. Okay, so it says, the measure of the angle formed is 1/2 the sum of the measures of the arcs intercepted. So, again, we drew these two. So my intercepted arcs are this arc and this arc. So it says, it's the sum of those two arcs. So how do I name this arc? AY. I'm going to put my little arc symbol over. The sum says plus, right? Obviously. Of the other arc, which is? JS. And then it says that, oops, sorry. I want an arc, not a. And then it says it was 1/2 the sum of that. So how do I show 1/2 of this? 2 different ways I can do this, right? I can just say divided by 2. Or I can put parentheses and say multiply by 1/2. Okay? Everybody okay with that? So realistically, this happens every single time, but there's 2 sets every single time, right? Now, if we look the other way, we would say that my arcs are what? JA and SY divided by 2 would be equal to, then if we went back and put 2 and 4 in there. The key to this is this. When it intersects, crosses on the inside, I'm going to add. So you got to put that connection into your melon. If they cross on the inside, you're going to add the arcs. Okay, now this is where a lot of people get confused. They're going to say, well, shouldn't angle 3's arc and angle 1's arc be the same thing if angle 1 and angle 3 are the same?
No, it's not.
Why isn't that true?
It's not on the center.
It's not on the center. So angle 1 and angle 3 aren't central angles. If they were, then my arcs would be the same as my angles. But obviously, this arc has to be farther apart because my line or my intersection dot is farther away from that side. And it looks bigger. Okay, but does that make sense what I'm saying there? So if that was dead in the middle, then those two would be the same. But it's not always going to be that. Okay? Questions there? Intersects on the inside, add them together. The arcs. They are 10, 13. If a secant and a tangent intersect at the point of tangency, then the measures of each angle formed is 1/2 the measure of the intercepted arc. Right? What are we talking about here? No clue, right? So, here we go. Draw a circle. Now try to draw a tangent to this circle. What's a tangent mean again?
It's at 1.1.
Okay. So I'm going to try to draw this tangent right here. And I'm going to put a dot right here. This is my what again from yesterday?
Tangency.
This is my point of tangency, right? And that's what they talked about in the theorem. Now, draw a line that hits that dot, but makes a secant. So it actually, the line has to touch the circle twice, but it has to go through that dot. Can you envision that? So draw a secant. Goes through that line, but touches my circle 2 times. Okay with that? So, I want you to think for 1/2 second here, because I know some of you can't go for more than 1/2 second because it might hurt yourself. What does that really kind of show? That we've already talked about? Okay, maybe. What else? In this chapter, what angle did we talk about after inscribed angles? And what was true about an inscribed angle? The vertex of that angle had to be where? On the outside of the circle. So once you consider this vertex of that angle right there,
Yeah.
and what was true about an inscribed angle and its arc?
1/2.
You had to multiply by 2 or divide by 2, depending on which way you're going. Remember all that?
Yeah.
Okay? To me, this is like an inscribed angle, so read it again. If a secant and a tangent intersect at the point of tangency, the measure of the angle formed, so I'm talking about this angle right here, let's call it 6. So the measure of angle 6 is, so there's my equal sign, 1/2 the measure of my arc. So let's come back and name some of this stuff. A and R. Brain room. So 1/2 AR. So basically it's like what Jackson was reading, right? If I'm talking about if I have the angle to get to this arc, I'm going to multiply by 2. If I have the arc, I'm going to multiply by 1/2 or divide by 2. So again, if you don't like this version of it, write this. Some of you like to divide, some of you like to multiply. I don't care. It's the exact same thing. But to me, this is an inscribed angle like Mr. Schettler came up with. Okay? Everybody good with that one? So, the first one they intersected on the inside, and we added. The second one they intersected right on the circle. So what's the last one going to deal with? Theorem 1014 is going to be when they intersect on the outside. So this one you can do it with 2 secants, a secant, and a tangent, or 2 tangents. So you can have a combination of all things. But let's do it with, this one to me is easiest to do with either a secant and a tangent, or 2 tangents. So I'm going to draw my secant. Ooh, that was kind of bad right there in the end. My apologies. And then it's going to intersect on the outside now, right? So come down here somewhere and put a point. Doesn't really matter where it is. And then draw either another secant or draw a tangent. I don't care which one you do. And then let's put a dot up here where my secant was formed. Now, what should we name them? I don't care. M, N, O, P. Okay? So, again, read what it says here at the beginning. If 2 secants, so we can really make this into a secant by just doing what? Moving it up just a little bit and extending it, right? That would be my 2 secants. Okay? A secant or a tangent, that's what we drew. Or we could have 2 tangents, and then we would just take this one over here and draw what we did kind of yesterday when we had the 2 that intersected on the outside. Okay? So, then it says, the measure of the angle formed. So where's the angle formed in this one? way down here and over, I'm going to name it angle 2 so everybody's talking about the same thing. Is 1/2 the positive difference of the measures of the interceptive arcs. So here are my two arcs. That arc and that arc. So some people just like to subtract them. But what they're saying is it should be the positive difference. So it doesn't matter if you do the smaller one minus the bigger one or the bigger one minus the smaller one. You're going to get the same number. The sign's just going to be different, right? One's going to be positive and one's going to be negative. You always want to just say that it's positive. I can't ever have a negative thing. So what this is saying is the measure of angle 2 is equal to MP, the arc. Again, I'm going to use MP because it's the bigger one, minus NP. And again, we should really have those little ends. And then what?
Divided by 2.
Divided by 2. And again, if you don't like the divided by 2 in these, you can just do the same thing, right? 1/2 times, and then write MP minus NP. Those two things right there are the exact same thing, right? But again, when they intersect on the outside, I'm going to subtract. When they intersect on the inside, I'm going to add my arcs together. Make sense? So that's the key to the whole thing. And then if it's right on the line, we kind of go back to the same rules that we talked about when we talked about inscribed angles. It's 1/2 of whatever we had. Questions here with the words, or pictures at least. Everybody okay with all that? All right, let's look at them. So the first thing, obviously, they kind of go in order here. So these are a little easier because you don't have to just stop and think, which one am I going to do? Now, obviously, in the homework or on the quiz and the test, we wouldn't go in that exact chronological order where it's going to be, inside, on, and then outside. So you got to kind of think about that. So, find x. How am I going to find x? I'm going to take what?
80 plus 76.
Right. So cross on the inside, so I got to add the two arcs together and then divide by 2. Okay, so I'm going to take 88 plus 76 divided by 2, and that's going to be x, correct? So in this particular case, if they asked you to find FIE, they could give me the exact same information, but then I'd have to what? Subtract it from 180. Everybody good with that? And understand what you're doing there? You need to see the math. Everybody's good? Okay? So this is the one that we just talked about. So now they give you these two arcs, but they're asking you for the other angle, so you still go through the exact same process we did. We find this, and then we subtract from 180. Everybody good with that? So in this one right here, I'm going to take 96 plus 62 divided by 2, and that would be this angle right here. But they asked me for this, so these two make up a line or linear pair. So I take my answer that I got right here. Here, I can show you this. So they got 79. 79 would go right here, and then I take 79 minus, or 180 minus 79 to get to this. Make sense? Okay. So what happens when we go the opposite direction? For whatever reason, when we go in the opposite direction at any levels, we get confused. But again, all you got to do is really plug it into the formula, right? So now, do I know what measure of angle 3 is? Yeah, I know that it's 60 degrees, right? And then I'm going to set it equal to, what are my two arcs? So I always like to put x first. It really doesn't matter, especially when you're adding, right? Because I can flip-flop addition. And then I'm going to divide by 2. So how do I solve for x here? I got to get rid of my fraction, right? So I'm going to multiply both sides by 2. And then after that,
subtract 25.
Subtract 25. So what's 120 minus 25? 95 is what? X or arc, JK. And then remember, all these are arcs or angles, so you should realistically have a degree symbol or say the measure of. If you say the measure of, then you don't have to have that degree symbol. But everybody okay with that math? So again, same principle, we're just going kind of backwards in that one. It's a good problem. So now we're on to the second theorem. Okay? So now we're having an intersection where it's right on the circle. Now notice here, they're asking us to find QPS. So the first thing you got to recognize is which way we're doing it. Because when I draw this, I actually make two different arcs, right? One arc right here, and then in this case right here, we just didn't extend this. So this could have been a tangent line. So if I extend this, we're going in this direction too. There's another arc right there that we could use. So if I have 250 as my arc, how do I get back to QPS? Divided by 2. So what's 250 divided by 2?
125.
125.
Wait, why do you do that? Divide by 2?
Because I'm doing this formula right here. 1/2 times the arc, or the arc divided by 2. So my arc is the 250 around the outside. But I'm going back to QPS. Okay, so if I have the arc, I take the arc and divide it by 2. Okay? So then obviously, like Jackson said at the beginning, if they give me the angle, then I take the angle and do what to it? Then I'm going to multiply by 2, right? So again, make sure that you read it though. Look at this one right here. So this one's trying to fool you a little bit. Find the measure of arc BCD. So they give us angle ADB. So the first thing I would do is find DB, the arc going this way. Right? From right here to right here is the one that I'm going to find by taking 108 and doing what to it? So what's 108 times 2?
216.
Okay, so is 216 my answer? No, because they want this. Remember, you got to go by the letters that they give you. So BCD is actually this arc right here. And so if we know that this is 216, what do I do with 216? From 360 this time because it's all the way around the circle.
Can you use a linear pair there and do the other?
You could do it the other way too, exactly right. So Shayla's saying, can I extend this right here and then do a linear pair first and then do the thing? You're going to get the exact same answer. Absolutely. So whatever way your melon sees it is how you would do that. Okay with that? Anybody needs to see the actual math? Okay? Another good problem. This is a good section. So here's the ones that I was showing you or telling you about. So we only drew it right here with a tangent and a secant. This would be the combination of all of them. Okay, so the one on the left would be 2 what? 2 secants, right? Because it touches, both of those lines touch 2 places. And notice they actually make a secant into 2 rays there, right? So it doesn't necessarily have to be 2 lines. Then the one in the middle would be a what and a what? Which one's my tangent? AC, right? And then my secant would be AD, okay? And then the last one would be what we did yesterday a little bit, right? So from yesterday, what do we know about AB and AC? They're congruent, right? That was from yesterday.
Wouldn't that be the same for?
That looks like that snow cone.
AB and AC?
AB and AC? No.
No? Oh, it's not going outside next year.
In the middle one or the first one?
First one.
The first one, it probably works, yes. But we'll get, that's going to be the last section, or the next section, okay? So, that was just a good thing. That's in your book too, if you need it. So here's where you got to be really careful and make sure that you read what they're asking you to find. So in this one right here, what am I going to do? So obviously I'm still down to this formula, right, or equation, because we're at 1014. So again, this one to me is kind of going backwards, right? Okay? Do I know what my angle is? My angle is 62. So I'm going to say 62 is equal to. Now, do I have the bigger one or the smaller one?
Bigger.
The bigger one. So I'm going to put this right here, and it is 141
Minus X.
minus x divided by 2 again.
Oh, it's just so.
Okay? What you got to be careful of is you could go and actually do x minus 141. But if you do it that way, where the smaller one comes first, your answer is actually going to come out negative. Don't freak out about it. Just know that you're basically going to take the absolute value of that then. Because you always want that. It's the same number, it'd just be negative. You know what I'm saying? Okay? So this one right here is kind of like what we did over here, but now it involves a subtraction sign instead of an addition sign.
What's the answer?
So if we do this one, we get what? 124 equals 141 minus x. I'm going to actually add x and then subtract 124. So we get what?
What's it?
17? Is
Yeah.
that what you guys got?
Yes.
So what does it ask?
What's smart?
BC.
So is that my answer?
No.
That's.
Yes.
This is my answer. This is actually 17 degrees because this x actually acts as what? BC? Arc BC. So that is my answer. Absolutely. I think there's another one I want you to see if I remember right. Well, I like the ice cream cone one. So again, basically the ice cream cone one is just your two tangents, right? So again, when they're asking you for this one, it's the exact same thing, but it's just a different looking shape. Okay?
Teardrop.
I thought it was an upside down ice cream
I
cone.
think it looks like a teardrop.
I think it looks like an upside down ice cream cone.
And all the ice cream. All the ice cream.
It's
would
whatever
fall
your
out.
melon thinks it is.
Maybe. Is
I'm
Melon
outside the box thinking.
Why you want to be sad and crying?
No, that's just what my brain thought it would be like.
All right, let's look at this one. The diagram shows the path of a light ray as it hits a cut diamond. The ray is bent or refracted at points A, B, and C. Everybody understand what the principle that's going on here? Okay, so you're shining in to a light and then it's just bouncing inside that kind of prism, or diamond in this case. A diamond is really a prism. Okay, if the measure of AC, so here's where I would really go through and start marking things down. Again, preferably not in your book. This is 96. Then what? S is 35. Sorry. Ooh, that was
Whoa.
And what is RBT? So where's RBT? So RBT is really just this right here, right? So in a sense, they want you to kind of ignore those two lines and you're just going back and doing what we did before. But it might be helpful to write it out. So realistically, we're still doing this one, right? Yeah, we're just doing this. But if you just kind of start going through with all those other lines, it does kind of get confusing. So again, take some time to write it out. Okay. This section, I know there's a couple pretty good ones in the homework, kind of challenge ones where they don't really give you specific pieces and they want you to find like this part over here. I think it's this section, maybe it's the next section, but. So again, make sure that if you're looking or trying to do the homework, that you look at all the problems. Okay? And again, the advantage of doing the homework is like today and going forward, you can use your homework on those few problems that you do. Oh, notice 53 through 58. Those of you that want a little tune-up for ACTs or the ISAFs, 53 through 58, you have to factor. So that'll be good for you. Practice is practice. So obviously, everything in the next couple days is going to be kind of haphazard.